Welcome back. Today we're going to start talking about something called a series. And just like we had arithmetic and geometric sequences, we have arithmetic and geometric series. Our goal today is to define what an arithmetic series is and to help find the sums of them. So a series is the sum of the terms of a sequence. It is finite if there is a last term, if the sequence ends. It's infinite if it continues without end. So if your sequence of numbers has a last term, we say it's a finite series. If it has the little dot, dot, dot at the end and it doesn't specify an end to it, then we have an infinite series. An arithmetic series is the sum of the terms of a finite arithmetic sequence. So our formula says the sum S sub n for a finite arithmetic series, where we are adding the first term plus the second term plus the third term all the way up to the nth term, the last number. The formula says we have to take n divided by 2 and multiply it to the sum of the first and last. Okay, so n divided by 2, and then we're adding the first term and the last term together. Okay. So the things we have to know: how many terms do we have in our series, and what is the first and last one? We're going to use the formula to find the sums of these instead of using a calculator to add them up. We're going to practice using this formula. So the first thing to do is figure out how many numbers do we have in our list. There is no little dot, dot, dot in the middle, so we aren't missing any terms. This is the whole list. So we have 1, 2, 3, 4, 5, 6. We have 6 numbers. So n is 6, my first term is 3, and my sixth term, my last term, which would be the a sub n in my formula, my last term is 38. So now it's just a matter of plugging them in. So we have s sub 6, we're adding 6 numbers together. We take 6 and divide it by 2, and then we add the first and the last together. So the 3 plus the 38 gets added together. Well, 38 plus 3 is 41, and 6 divided by 2 is 3. So we get 3 times 41, which would be 123. Now I want you to understand why we are adding the first and last and then multiplying it by n divided by 2. If we look at what happens when we add the first and last together, we said we got 41. When we add the next two inside, so the 10 and the 31, we also get 41. If we add the 17 and the 24, we get 41. So each of those sums gets us 41. And if you look at, we had 6 numbers, we pair them up, we have 3 pairs that all add up to 41. So we have 3 pairs, each pair adds up to 41. We simply multiply those together. Okay, next example. Again, we count our terms, 1, 2, 3, 4, 5, 6, 7 terms this time. So our n value is 7, and we know that our first term is a 5, and our last term, which in this case would be the 7th one, since we're adding 7 numbers together, is a negative 19. Okay, make sure you take that sign with it. So our formula for the sum of those 7 terms, we're going to take 7 divided by 2. We add the first term, 5, with the last term, negative 19. Okay, well, 5 plus negative 19 would be negative 14. We're multiplying by 7 divided by 2. We could take 2 and 14 and reduce that to 1 and negative 7. So we end up with a total of negative 49. All right. Now, obviously, when we have a complete list of numbers like we had here, we could just type them in our calculator and add them up. The problem is we aren't always going to have that. So to use our formula, we have to know n, our first term, and our last term. So how many numbers are in the list, and what are the first and last numbers? We want to identify the pieces that we know. Do we know the first term? Do we know the last term? Do we know our n value? Sometimes we have to figure out our d value to help us find one of those other terms. All right, so looking at what pieces do we know and what are we still missing, we can use the explicit formula, which we've included in your notes again here, to figure out any missing piece, and then we can plug them back into that sum formula that we just were working with, okay? So notice on this next example, there's a dot, dot, dot in the middle. That means I can't simply just count my terms because I don't know how many terms are in that little section. All right, so we don't know what n is. But I do know that my first term is 4, and I know that my last term, whether we don't know what the n value of it is, but we know that the term itself is 99. We can also figure out what our common difference is. If we compare, we are simply just adding 5 each time. So my common difference is 5. And I can use that information to work back and figure out n. All right, so let's plug this into our explicit formula. We get an answer of 99 when we started with a first term of 4, and we added an unknown number right now, an unknown number of these common differences of 5. Okay, so simplifying, we've got 4 plus 5n minus 5. Combining like terms, we have 5n minus 1. We can add 1 over to the other side and then divide. So it looks like our total number of terms should be 20. So now I can use that to figure out my sum. The sum of those 20 numbers. We take the total number of terms and pair them up. So we're dividing by 2 to pair them up. And then each pair of numbers is equivalent to the first term plus the last term. So 4 plus 99. So 4 plus 99 is 103. 20 divided by 2 is 10. So our total here would be 1,030. All right, looking at our next one. What do we know? We know that the first term is 30. We know that the last term is negative 26. We do not know what n is, but we can figure out that our common difference, we are subtracting 7. So remember, to find d, we can take the second term minus the first term. So my d value is negative 7. All right, knowing all of that, I can figure out how many numbers are in my list. So a sub n equals first term plus n minus 1 times my common difference. Plugging in what we know. Our first term is 30. We don't know n. We know d is negative 7. And we know that our nth term, our last term, is supposed to be 26, negative 26. All right, distributing on the right side here. We get negative 7n plus 7, which would be 37 minus 7n. If we subtract 37 over to this side, we have negative 7n equals negative 63. So that means n would have to be 9. Okay, so now we can find the sum. The sum of those 9 terms is going to be 9 divided by 2, and then we're adding the first term, 30, and the last term, negative 26. Well, 30 plus negative 26 would just be 4. We have 9 halves times 4 would be the same as 9 times 2, or 18. So my total for those 9 terms is 18. All right. Now, for this next 2, we're given slightly different information. We still have our first term. In this case, a sub 1 is 1. I still can figure out my common difference. To go from 1 to 3.5, I added 2.5. To go from 3.5 to 6, I added 2.5, etc. So my common difference is 2.5. I know that n is 12. What I don't know is a sub n. I don't know the 12th term in my list because the list ends with just this dot, dot, dot. So there's no final number listed for me. but this tells me that I only want 12 numbers in the list total. So it is a finite list, even with the dot, dot, dot there. I just don't know what that last term is. So we're going to figure it out. A sub n equals my first term, which is a 1, plus n minus 1, and this time we know n is 12, times our common difference, which was 2.5. All right, so we have a sub n equals 1 plus 11 times 2.5. Adding that up, we get 28.5. So that's my 12th number, my last number in that list. Okay, so now I can find the sum of those 12 numbers. I'm going to take all 12 and pair them up, so divide it by 2. I have 6 pairs of numbers. Each pair is the total of the first term plus the last term. So we have 6 times 29.5. We end up with 177. All right. So I would like you to pause the recording and try this next one, and then turn it back on when you are done. Okay, let's check what you came up with. We know that there are 10 numbers in our list. We know our first term is 20. And if we figure out our common difference, 18.3 minus 20 would be negative 1.7. We're subtracting 1.7 each time. So let's figure out what is that 10th term. All right, we start with a 20. We're adding 10 minus 1 of those common differences. So we have 20 plus 9 times negative 1.7. We end up with 4.7 for a total there. So the last number in my list, a sub n in my list, would be 4.7. So let's find the sum of those 10 numbers. We're going to take those 10 and pair them up. Each pair is equivalent to the first plus the last. All right, so we've got 24.7 times 5. And we end up with 123.5. All right. This one we're not given a list of numbers, but we're told enough information to help us generate that list. It says, what is the sum of the even integers from 2 to 100? So even integers would be like 2, 4, 6, 8. And we want to go all the way up to 100. Okay, that's my sequence of numbers. Now, they're asking me for the sum of it, so they want me to add those all up. Well, what do we know? We know our first term is 2. We know we have a common difference of 2 because they're even integers. We're going every other number. 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. Common difference is 2. That'd be the same if it said the sum of the odd integers as well. Common difference of 2. We don't know our n value, but we know that our last number in the list has to be 100. All right, so let's work back. A sub n equals first term plus n minus 1 times d. Times d. All right, plugging in what we know. Our last term is 100. Our first term was 2. We don't know our n value, but our common difference was also 2. All right, so distributing, we've got 2n minus 2. Combining, it's just a 2n. So 100 equals 2n. N would then have to be 50. So there's 50 numbers in that list. So now to find the sum of our 50 numbers, we take those 50 and pair them up. So 50 divided by 2, each pair adds up to the first plus the last. All right, so we end up with 25 times 102. Our total should be 2,550. All right, our last question. It says a company pays a $10,000 bonus to salespeople at the end of their first 50 weeks if they make 10 sales in the first week and then improve their sales by 2 each week thereafter. One salesperson qualified for the bonus with the minimum possible number of sales. How many sales did the person make in week 50 and in all 50 weeks? So we have two questions here. How many did they make in week 50? Just means find the 50th number in that list. Okay? In all 50 weeks, now they're saying what's the total, the sum of those 50 terms of my sequence. All right, so let's look at our sequence. We are told that the first week they make 10 sales. So A sub 1 is 10. And then they improve their sales by 2 each week after that. So our common difference has to be a 2. All right. We know that there are 50 weeks in this process, so n equals 50. So looking at our sequence of numbers, we start with a 10, we improve it by 2 each week. So the next week we would have to have 12, then 14, etc. All right? What we have to figure out is how many did we make in that last week, A sub n, and then we can find the total for all 50 weeks. All right, so we want to find A sub 50, the last number in my list. We take our first term, 10, plus, we know that there's 50 terms, so 50 minus 1, we're going to have 49 of these common differences, and each common difference was a 2. So we have to add 2 49 times to get to that last number. So 49 times 2 would be 98, plus 10 would be 108. So that is my 50th number. In week 50, they have to make 108 sales. Now to find the total sales for all 50 weeks, we take the n divided by 2, so 50 divided by 2, times the first term, 10, plus the last term, 108. So 50 divided by 2 would be 25. 10 plus 108 would be 118. Multiplying 25 and 118 should get us 2,950 sales. All right, so you guys are going to start working with arithmetic series using the worksheet 9.4a. Let me know if you have any questions.